Hi, this is Mrs. Clark, and welcome to my video about using scale factor to determine surface area and volume. You have this worksheet. Please cut it out. So notice you'll cut all the way along the dotted lines, all the way around, and you'll end up with this interesting shape here. What you're going to do is cut a little slit between here and this dotted line, and it's going to end up folding together like this. Okay, so it's going to look like this in your notebook. So we're going to have one tab that's talking about the volume and another tab that's talking about the scale factor. Sorry, the area. Area, surface area, any type of area. So when we open it up, we're going to do the volume first. It's on the top tab says volume, so this top part is going to be our volume examples. And we're going to use what we know about scale factor and proportions to find the missing piece here. Okay, so if we look at this first example, it says the scale factor of two similar rectangular prisms is 2. So that means K is equal to 2, and I'm going to put that over 1 because our scale factor is always something over something. If we notice on the front here for volume, it says if the scale factor of the sides is A over B, then the scale factor of the volume is, and here we're going to put A to the third power over B to the third power. So volume is a 3-dimensional measurement, whereas scale factor is a 1-dimensional measurement. So that's why it's to the third power, because it's 3 dimensions. Okay? So when I'm looking at the scale factor of this first example, it's 2 over 1. That means my larger number is on top, my smaller number is on the bottom. The second part of the example says if the volume of the smaller prism is 15 cubic feet, find the volume of the larger prism. So we're looking at volume here. And since we're looking at volume, we're going to use that same idea that we just wrote down on the front. The scale factor is going to be A cubed over B cubed. So if I'm thinking of larger on top, smaller on the bottom, I'm going to go ahead and cube both of these numbers. So I'm going to do 2 cubed over 1 cubed. And that's going to be equal to the ratio of the volumes. So it says the smaller volume is 15 cubic feet. This part is just the units, so it doesn't have to do anything with the 15. It's just the label that goes with it. But since 15 is the smaller prism, I'm going to put that on the bottom because the smaller part of my scale factor is on the bottom. So here I'm going to write 15. And I need to know the volume of the larger one. Larger is on top, so I'm going to put an X here. It's going to be really simple for me to solve. I have to cross multiply and divide to solve for X. But before I can do that, I have to actually cube out both of these numbers. So that means I have to do 2 times 2 times 2 for the top and 1 times 1 times 1. So if I do 2 times 2 is 4 times another 2 is 8. So this is really 8 over 1 times 1 times 1, which is just 1. So our scale factor for volume is going to be 8 over 1. And that's going to equal X over 15. We're going to solve this our traditional way of cross multiplying. 1X equals 8 times 15, which is 120. And luckily I don't have to do any dividing here because it's already 1X. So X is equal to 120. So that means the answer to our question, which is the volume of the larger prism, is 120. So I'm going to write that here. Let me write it over here, actually. Volume of larger prism is 120 cubic feet. So there's our final answer. Okay. So go ahead and pause the video for a second and try the second example, see what you get, and then check back to see if you're correct. Okay, this example is a little bit different. And I'm wondering if when you were doing it, you could figure out where the scale factor is in the problem. So it says a bottle has a volume of 200 milliliters and a height of 12 centimeters. Another similar bottle has a height of 18 centimeters. What is the volume of this bottle? So notice we were given the height for one and the height for the other. So we're going to get our scale factor from there. So our scale factor K is going to equal 12 over 18. Now you could make yours 18 over 12 if you want to. I just chose to do it in that order. But since I'm looking for volume, I'm going to have to cube these numbers in order to use them in a proportion. So I'm going to do 12 to the third power over 18 to the third power equals, and then let's fill in what I know. I know the first bottle has a volume of 200, and I don't know the second bottle. So the first bottle was the one that went with 12, so that's going to be here, 200. I don't know the volume of the second bottle, so that's going to go there. Okay? In order to solve this proportion, I'm going to have to cube out those numbers. So that means I have to do 12 times 12 times 12, and 18 times 18 times 18. Now in the calculator, 12 times 12 times 12 gives me 1,728. 18 times 18 times 18 gives me 5,832. That's going to be equal to 200 over x. So I'm going to do my cross multiplying. I'm going to do 1,728 times x. So that's 1,728x equals, and then I have to do 200 times 5,832. So when I did that in my calculator, I got a long number. Actually, I'm not going to have enough room here. Let me change this equal sign. Put it on this side. And the number that I got was 1166400. So 1166400. So in order to solve for x, I'm going to have to divide both sides by 1728. And when I do that, I get 675 equals x. So that tells us that the volume of the other bottle is 675 milliliters. All right. So there's a couple of examples using volume. Anytime I'm doing volume, it is a three-dimensional measure, so I have to remember to take my scale factor and bring it to the third power. Now, these next two examples are about surface area. And surface area, as we know, is a type of area, which is a two-dimensional length times width measurement. So when I'm looking at the scale factor of the sides, A over B, I'm going to know that it's an area, but so now I'm going to do two dimensions, which means I'm going to have to do A squared over B squared. So whatever my scale factor was, I'm going to square it top and bottom. Okay. So that's going to be, I'm sorry, that B looks like a 6. That's going to be what I'm going to use for these next two examples because they're about area. Okay. So on the inside here, let's take a look at these. The scale factor of two similar rectangles is 5. If the area of the smaller rectangle is 7 feet squared, and find the area of the larger rectangle. So scale factor is 5, k equals 5 over 1. That means I have large on the top, small on the bottom. And I'm looking at an area, so I'm going to square both of these. 5 squared over 1 squared. And I'm going to make my proportion using the squared versions of these. So it says the smaller area of the smaller rectangle is 7, so that's going to go on the bottom because my small number is on the bottom. And I'm looking for the area of the larger one, so I'm going to put an x there. So in order to continue on with this proportion, first I've got to square both those numbers. 5 times 5 is 25. 1 times 1 is 1, so it's 25 over 1 equals x over 7. Do my cross multiplying. 1 times x is x, or 1x. 7 times 25 is 175. I don't have to divide because I have 1x equals 175. So the area of the larger rectangle is 175. So let me write that down. Area of the larger rectangle is 175. Let's add a label on here, feet squared, or square feet. There's that one. So here would be a good time for you to pause it again and try and see if you can figure out the second problem, and then check back to make sure you're correct. Okay, here's my work for the second problem here, and let me go through a quick explanation of it. So a box has a surface area of 3.5 square meters. If the length of the box is increased by a scale factor of 4, what would be the new surface area? So first I wrote down k equals 4 over 1, my larger one on top, smaller one on the bottom. And it's telling me that 3.5 was what it was, and then it increased by a scale factor, so it enlarged. So if that means 3.5 is my smaller, and I don't know what my larger one is. So I put my 3.5 on the denominator, my x on the top, because that was my larger one. And I made that equal to 4 squared over 1 squared, because we're doing an area problem, even though it's surface area and not just regular area. I have to square my scale factor. So 4 squared over 1 squared equals x over 3.5. Then I do 4 squared. 4 times 4 is 16. 1 squared, 1 times 1 is 1, equals x over 35. I cross multiply. 1 times x is x. 16 times 3.5 is 56. So that tells me that my new surface area will be 56 meters squared, or square meters. All right, and there are our 4 examples of how to use a scale factor to find a missing surface area or a missing volume. Go ahead and fold that up and then use this back side here. Put your glue on this part and glue that into your notebook. Let me know if you have any questions. Thanks for watching.